Hello, welcome to Unit G, Lesson 6 note sheet. In this note sheet, we are going to be focusing on how to draw the graph of a function that represents a real-world situation. So we're going to be connecting it back to that real-world connection. Let's take a look at the warm-up. So here we have 5 pictures of a dog taken at equal intervals of time. Diego and Lynn both draw different graphs to represent the situation. They both use time as the independent variable, and they want to know, what do you think each one used for their dependent variable? So if you recall, our independent variable is our input, so that tells us that time goes on the x-axis. Now, when I look closer at Diego's graph, I noticed that the starting point of the dog, which is going to be the y-intercept, starts a little bit closer to that origin 0, 0. So that means whatever my y-axis is, whatever I think of that labeling going to be, it's going to have to be something that's closer to 0, whereas Lynn's graph is kind of the reverse of Diego's graph. For Lynn's graph, it actually starts farther away from you and then gets closer as time goes forward. So if we look at the pictures, we can see the dog is laying down for the first couple of frames. That explains why there's no movement here and here. It's just kind of sitting still. But then it gets up and it starts running closer, which then explains the straight line after the fact. So now let's get into, why would Diego's graph start closer to 0? Well, you would start closer to 0 if you were saying, we're talking about how far is the dog from the edge of the grass, right? So when we're in these 2 frames right here, the dog is pretty close to the edge of the grass. So maybe my dependent variable here is distance from edge of grass, because notice in the later 2 frames, when the dog starts running, it gets further away from that 0, so it's because it's getting further away from the edge of the graph. Now, this is different from Lynn's story, because Lynn has a bigger distance to start with, and then has the dog getting closer to you. So instead, I would say this would be distance from you. So wherever you are standing, or you can even say from your camera, since we took pictures, but it's going to be that distance, because as the dog started running, it's starting to get closer to that x-axis, which we can anticipate where whoever's taking these pictures stand. There's other descriptors that you could use as well, but the key thing is whichever one you choose for Diego should have that distance getting bigger when the dog starts running, and whichever variable you choose for Lynn, it should have that distance getting smaller as the dog started running. All right, let's look at the next activity. All right, for this activity, we have a couple of situations, and what you're going to need to do is first identify the independent and dependent variables, choose the graph that best fits that situation, or sketch one if it isn't provided, label the x and y axes, and then answer the question, which quantity is a function of which? Be prepared to explain your reasoning. So you should have a good explanation as to why. So go ahead, pause the video, and work on that. All right, let's take a look at question A. All right, Jada is training for a swimming race. The more she practices, the less time it takes for her to swim 1 lap. So in this case, we're talking about practice time, and the more she practices, so practice time, and then in time it takes to swim swim 1 lap. So in both cases, we're talking about time, the amount of practice, and then the amount of time it takes her to swim that lap. So when we're thinking about independent versus dependent, the dependent one should always have a role that comes from the independent variable. So in this case, I know the time it takes her to swim 1 lap depends on the amount of practice. So this is going to be time for 1 lap, and then this is going to be independent is going to be amount of practice time. So independent variable is the amount of practice time. Dependent variable, which will hopefully decrease as she practices more, is going to be our time for one lap. Now we needed to choose which graph best suits the situation. So we have two that are facing kind of opening upward-ish, and one that's kind of opening downward-ish. They're both, all of them are curves. So have to ask ourselves, as X increases, so as practice time increases, we want the lap time to decrease. We want that to go down. So as X increases, we want Y to decrease. And when we look at the last one, we can tell right off the bat that that one is not going to make sense, because as X increases, Y is actually increasing. So that's not going to be necessarily the graph that we think represents the amount of time that it takes to swim one lap, because that time should be getting smaller. So right off the bat, I can cross off that graph. When I analyze the other two graphs, this middle one kind of stays flat for a little while, right? It's flat, 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 and then it starts to curve up. So it's kind of made up of these two motions. One is as X increases, Y is staying flat. And then the other one is as X increases, Y is starting to increase as well. And again, we want the amount of time to decrease for one lap, not increase. So that eliminates this one for us. So the only one that truly shows a lap time decreasing as the amount of practice time increasing is going to be our first graph. So this is going to be the graph right here. And we talked about labeling the axes. I already kind of did that. So for this one, we would say the x-axis is the amount of practice. And maybe we're doing this in minutes. And then my y-axis would be number of maybe minutes per lap. So that is going to be my x and y axes. And then it has you answering the question, which quantity is a function of which? Be prepared to explain your reasoning. So just remember, when we're talking about a function of another, a variable is a function of something else. The easiest way to always remember is that your output is always going to be a function. Output is function of input. And input and independent variable are the same thing, so they do not rely on anything. So in this case, we would say the number of minutes per lap is a function of the amount of practice time. All right, let's take a look at B. Now B says Andre adds some money to a jar in his room each week for 3 weeks and then takes some out in week 4. So what is the independent and what is the dependent? And then this one we have to sketch our own and then still do the x and y axes and answer the question, what is a function of what? So right off the bat, I know that the amount of money in Andre's jar is going to be dependent on the number of weeks, right? Because as the more weeks happen, we're either increasing our money or decreasing our money, depending on what your labels are. So I would probably say that my dependent variable is going to be amount of money in jar. Money in the jar. You could also say it's the amount of money coming out of the jar, depending on how you phrased it. I just went with the amount of money in the jar, which makes my independent variable the number of weeks. So I can go ahead and label my X and Y axes. Here's going to be number of weeks. And then here's going to be dollar amount in jar. So it says that he is taking, he adds money to his jar for each of 3 weeks and then eventually takes out some in week 4. So in general, I'm going to draw a straight line to represent each week. So for example, maybe from 0 to week 1, that's the amount he has, and he pulls it out, or he adds money in. So then from week 1 to week 2, he's got a little bit more money. Week 2 to week 3, he's got a little bit more money. But then on week 4, it looks like he went down because he took out some money. So this is more what your graph is going to look like. You could have you could have written not a bunch of smaller lines, but you could have made it more of a curve. But you should show that as X is increasing, Y is increasing for the first 3 weeks, if you talked about the amount of money in the jar, and then a decrease for after 4 weeks. The final question is, what is a function of what? So remember, our output is always a function of the input. So we would say the dollar amount in jar is a function of the number of weeks. All right, last but not least, let's move on to the next activity. So here's a story. It says Noah was at home. He got on his bike and rode to his friend's house and stayed there for a while. Then he rode home again. Then he rode to the park, and then he rode home again. So the first thing you're going to do is create a set of axes, which the axes have already been created for you, but you're going to want to label the quantities, and you're going to want to create the story create the graph, based on the story, and then take a moment to answer the rest of the question. So go ahead, pause the video, and then come back to it. All right, so let's start with sketching this story. So again, depending on how you approached it, your graph could look differently, and I'm going to show you one way. Regardless, our independent variable is going to be time, and this time we're going to be talking about hours instead of minutes. It doesn't make sense to only spend a couple minutes at a park, but maybe an hour or two, that's a little bit different. Now, the other thing that I might try to do is say this is distance from home, and we're going to be measuring in miles. Again, it may look different. Maybe you said distance from the park, or maybe you said total distance traveled. So it really just depends on what you're labeling that dependent variable as. All right, so let's go ahead. If I'm talking with distance from home and I go with the story, Noah's home would then be at the origin. 0, 0, no time has passed, and he's 0 miles from the house. Then he got on his bike and he rode to his friend's house. So maybe it took him about, I don't know, an hour to go. I think 5 miles is appropriate, an hour to go 5 miles. So I would go up like that. And then it says he stayed there for a while. So maybe he stayed there for about 3 hours. Then he rode home again. So he rode home probably about there. Now he's back home. And then he went to the park. And the park is probably not as far, so it's not going to take him as long, maybe only a half an hour. And then he stayed there for an unknown amount of time and then rode home again. So your graph would look something like this. If you used a total distance traveled for your dependent variable, it would be instead a graph that's ever increasing. There are some points when it doesn't increase and it's flat, but there are going to be times when it does increase in general, so that it should be in a continuously increasing manner. All right, 2 labels I've already discussed. Okay, which quantity is a function of which? So in this case, I said distance from home is a function of time. Okay. And then based on your graph, is your friend's house or the park closer to Noah's home? So based on my graph, I know that the friend's house is closer. Friend's house is closer because he only needed about 30 minutes of travel time to get there. All right, so that's question D, and I think that is all we have. So that's it. Just remember, with functions, overarching idea, the output is always a function of the input. Input is the same as the independent variable, and we know we have a function when all inputs have exactly one output. So that's it for this lesson. Thanks for watching.